What is the acceleration due to gravity, g? Imagine dropping a ball and watching it fall faster and faster. That speeding up is what scientists call the acceleration due to gravity, often written as g. It's the rate at which objects increase their speed as they fall toward a massive body like Earth because of gravity's pull. Near the surface of Earth, this rate is about 9.8 meters per second squared. That means every second, a falling object speeds up by roughly 9.8 meters per second, assuming air resistance doesn't slow it down. This number is a standard used in science and engineering because it helps us understand how objects move under gravity's influence. But this value isn't exactly the same everywhere on Earth. It can vary slightly depending on where you are. For example, at higher altitudes like on top of a mountain, gravity is a little weaker because you are farther from Earth's center. Similarly, gravity is slightly stronger at the poles than at the equator because of Earth's shape and rotation. These tiny differences matter in precise scientific calculations, especially in fields like surveying or satellite navigation. Understanding G is important because it influences how we build structures, design vehicles, and even how satellites orbit our planet. When launching rockets, scientists need to know exactly how gravity affects their trajectory. Spacecraft moving between planets also depend on gravity calculations to determine their paths. Beyond Earth, every celestial body has its own gravity. The Moon's gravity is weaker, so objects fall more slowly there. On Mars, gravity is about 3.7 meters per second squared, less than half of Earth's. In the universe, gravity is a fundamental force that acts on everything with mass. It's what keeps planets orbiting stars and moons circling planets. The strength of gravity depends on the mass of the objects involved and how far apart they are. Larger objects exert a stronger pull, and the farther away you are, the weaker the effect. So, the acceleration due to gravity is not just about Earth. It's a universal rule that shapes how everything moves in space. In simple terms, the acceleration due to gravity is how quickly an object speeds up when falling toward a massive body. It's a key concept that helps us understand the motion of objects on Earth and across the universe. Whether you're dropping a ball or calculating the path of a spacecraft, knowing G is essential for making accurate predictions about motion and force.